Before we can understand ordered pairs, we need to understand where ordered pairs are plotted. You've previously plotted values on a number line. This line traditionally represents the x-axis. When you graph on one axis, you're graphing in one dimension. In order to graph in two dimensions, you need two axes. A coordinate plane has an x-axis and a y-axis. This is a coordinate plane. You can observe that the coordinate plane has two axes. The x-axis is horizontal. The y-axis is vertical. You can sometimes remember this with y to the sky. The y-axis is pointing up to the sky. As the different values from these two different axes cross, we get a graph. This creates our coordinate plane. The coordinate plane is broken into four different quadrants. 1, 2, 3, and 4. The horizontal axis is the x-axis. The vertical axis is the y-axis. All positive coordinates are located up and to the right. All negative coordinates are located down and to the left. This concept of positive and negative will come in handy as we're plotting and naming points, as well as when we're graphing or reading slopes. All values in the first coordinate are going to have a positive ordered pair. If it's in the second coordinate, it's going to have a negative positive coordinate. The third quadrant has a negative ordered pair, and the fourth quadrant has a positive ordered pair. This will come in handy as we start to name and plot ordered pairs. It'll help us as a quick check to make sure that our ordered pair matches the format for positive and negative signs of the coordinate it's located in. An ordered pair is a set of two coordinates that tell you where a point is located. An ordered pair also represents a solution to a linear equation. The ordered pairs go in alphabetical order. We have our x-coordinate and we have our y-coordinate. A linear equation has both x and y variables. If I plug in my x-coordinate for x and substitute in my y-coordinate for y, and I get a true statement, that means that that point is located somewhere on the line. Now that we're familiar with the coordinate plane and the format that will be given our ordered pairs, we need to understand how to plot them. We always start by looking for the origin. The origin is a very special ordered pair. It is the point that's located at 0, 0. It's dead center of our coordinate plane. We start at the origin every single time. You put your finger there, you put your pencil there, your focus is on the origin, 0, 0, dead center. Then we're going to start moving to our actual point. Move left or right the number of spaces in the x-coordinate, starting at the origin. If it is negative, go left. If it is positive, go right. All left values are negative, all right values are positive. Since our x-coordinate is positive 4, I'm going to go to the right 4 spaces. So I move over 4 spaces. Now I've taken care of my x-coordinate, I take care of my y-coordinate. From the position I ended at, I'm going to move up or down the number of spaces in the y-coordinate. From where you ended. If it is negative, go down. If it's positive, move up. I have -2 as my y-coordinate, so I'm going to go down 2. I started at the origin and moved 4 to the right because I had a +4 for my x-coordinate. Then I moved down 2 spaces because I had a -2 y-coordinate. Step 3 picks up where step 2 left off. That is where my point is located. That point on my coordinate plane represents 4 commas. Let's try a few together. If it helps, you might need a little reminder, whether it's left, right, up, down. I have 3, 5. 3 is my x-coordinate, so that's where I'm going to go left or right. 3 is +3. right is positive, left is negative. So I'm going to start at my origin, and I'm going to go 3 to the right. That's step 2. Start at your origin, then move to the left or right. My y-coordinate is positive 5, so I'm going to go 5 up. Up is positive, down is negative. I pick up where I left off in the last step. Now I'm going to go up 5 spaces. From the origin, I've gone 3 to the right and 5 up. I've given myself directions to find my next ordered pair. That's where my point is located. The next example, -2, 1.5. -2. So I'm going to start at my origin, and I'm going to end up going 2 to the left, because -2 is left. Now I'm going to look at my y-coordinate, which is 1.5. It's positive 1.5. So I'm going to go 1.5 steps in the upward direction. Up is positive, down is negative. In order to do 1.5, that's 1.5. I'm going to go up 1 and then about halfway through the second. From the origin, I went 2 to the left because my x-coordinate was -2. Left is negative, right is positive. Then I went up 1.5. Up is positive, down is negative. For the next example, I have -2, -4. -2, my x-coordinate. I'm going to start at the origin, and then I'm going to go 2 to the left because it's -2. Now I'm going to go -4, which is my y-coordinate. That's 4 down. Up is positive, down is negative. So starting where I ended off when I found my x-coordinate, I'm now going to go down 4. I went 2 to the left because -2. I went 4 down because of -4. That's where I'm going to plot my point. I can double check. My x values, or x-coordinate, is still -2 because it's 2 to the left off of the x-axis, and it's 4 down from the y-axis. On your own, try plotting the other 3 problems. And then answer the question below. Is 8, -5 the same as -5, 8? Put it in your own words. If we're given an ordered pair, we can plot a point. If we're given a point, we can name the ordered pair that's connected to it. To do so, we count from the y-axis to the point. Right is positive, left is negative. So in point A, that point, if I start at the y-axis, it's 1 coordinate, or 1 step away from the y-axis. So my x-coordinate is 1. You can also see that if I follow that dot straight down to the x-axis, it lines up with the number 1. Not all coordinate planes have numbers written on them, however. We're going to do the same thing for point B. I'm going to start at the y-axis. It's 2 points to the left, or 2 steps to the left, to give me -2. That's how I find my x-axis, or x-coordinate. I'm going to now count from the x-axis to the point. Up is positive, down is negative. So I'm going to line up right underneath point A. I'm going to count up 2. So that's 2 as our y-coordinate. For point B, I'm going to start at my x-axis and count down as well. It's down 1, 2, 3, so that's -3. Other options for naming ordered pairs involve counting from the origin, count how far left or right you've moved, and then count how far up or down you've moved. It's the same idea. In this case, though, we're just looking at it relative to the x and y axis. Let's try a couple problems together. Point A. Point A is 1 step to the right from the y-axis. That means I have an x-coordinate of 1. It's 1 step below the x-axis. So that means I have a coordinate of 1. But be careful. It's not just 1 step. Because I had to go down to get to that point, it's -1. Point B, We start by looking at how far away from the y-axis point B is. It's 3 to the left. Left is negative, right is positive. Up is positive, down is negative. Then we count up from the x-axis. That's up 3, so it's positive 3. Up is positive, down is negative. On your own, try naming the other 3 ordered pairs on this sheet. An intercept is a very specific type of point. It's the point where a line intersects an axis. This is the point where a line crosses x or y axis. When the point is on the x-axis, it's called an x-intercept. When the point is on the y-axis, it's called a y-intercept. Let's observe these x and y intercepts to find any trends in how their ordered pairs are organized. Let's look at the blue line. The blue line is crossing the y-axis, so it's a y-intercept. As an ordered pair, it's 0, 8. Since it's on the y-axis, it's not going left or right from the y-axis. However, it's 8 above the origin. So 0, 8 is the ordered pair for this particular intercept. Let's look at the red line now. The red line is an x-axis, or x-intercept, because it's crossing the x-axis. To find our x-coordinate, we count how far it is away from the y-axis. It's 1, 2, 3, 4, 5 to the left, so that's -5. But because it's on the x-axis, it's not above or below it. So we have 0 for our y-coordinate, -5, 0. If we look at the green line, it has both an x-intercept and a y-intercept. Our x-intercept is 7, 0, because it's 7 away, or to the right, from the y-axis, but then it's right on the x-axis, so the y-coordinate 0. Its y-intercept is 0, -6, because we don't go left or right, so there's no x-coordinate other than 0, and it's down 6 steps from the origin, -6. All of these ordered pairs contain a 0. Based on the type of intercept, the 0 becomes very important. It'll be a reminder of either what type of intercept we have, or if we're writing the ordered pair, it'll remind us where to write the 0. If we observe, all x-intercepts have some kind of x value or x-coordinate, and then have 0 for the y-coordinate. Y-intercepts are exactly the opposite. All x-coordinates on a y-intercept are 0, and then there's a value or a y-coordinate for the y-coordinate.